I think we are live. Yo, what's up, everybody? We are live. It's late, so late OP. I am caught up in a lot of other things, so we'll be keeping this stream short because I have something else to attend to after this. So we only have about half an hour, so we'll keep this stream very short. So anybody joining at the end, you'll never know what happened, why we kept the stream short. And for everybody watching in the future, yes, we kept the stream short. We'll try at least. So the agenda this time is we're trying something new. We're going to build our own GoLang chat protocol. GoLang is only here for implementation. So the protocol itself is basically similar to an RFC, okay, which is like request for change, if I'm not wrong. That's what RFCs are. Oh, no, it's called request for comment. Okay, so a protocol basically is a set of rules. So you can consider a protocol like a rule book on how things happen. That is what protocols are. And HTTP is a protocol, gRPC is a protocol. You have many other protocols. You have SMTP, you have RTMP, RTSP, a lot of protocols. But each of these protocols is basically a set of rules that define how certain things happen. So in terms of HTTP, it defines how data is transmitted in the text form over a TCP connection. That is what HTTP defines. Okay, so that is the protocol. And what HTTP protocol defines is how a single frame or a single message should be structured so that you could implement a codec for. Codec is basically a coder decoder, or you could call it like a encoder decoder mechanism. So because over the network you're sending bytes, so when you're getting bytes you should know how big a message is, so you could decode it accordingly. So HTTP basically defines that structure based on which you could implement your own encoder and decoder. So encoder is certain format into bytes and decoder is bytes into certain format. Okay, provided that the formats are encodable. So what we'll be doing is trying to understand what HTTP does in this very short stream, and we'll also try to uh, analyze or basically mark out what our protocol should do or how our protocol should be structured. There are a lot of things to consider in a protocol. That is why these are RFCs. RFCs are basically like proposals on which other people, other smart people can comment. And then based on that, you'll basically bring out the most legible, most optimal ideas out of it. So other people would read the whole proposal, would understand the whole thing, understand your approach, and then try to figure out like, okay, what I think is this is how you should do it, or this is not valid, or whatever similar. So there are a lot of things, message syntax and routing. So these are so this document that I have here, I'll drop this document in the chat box here. So if you want, you could go ahead and read it. This is the document, and this document is basically an updated RFC to the old RFCs, and this RFC basically introduces a lot more, a lot new things. So this RFC introduced, it basically says that there are a few things that this RFC does, and here history and evolution. You can see that HTTP simply began, then it had this version system of HTTP slash certain version. So we had HTTP 0.9 and then HTTP 1.0, which by default we use. And then we also had some more developments, and then we got HTTP 1.1, which was basically a refinement over HTTP 1. And then we also had like some length limitations, delimiter limitations, dynamic chunk, a few different things. So there are a few things that we need to understand before we start implementing the protocol. But yes, it is also important to know how other protocols are built so we can write our own. HTTP 1.1 basically was like upgrades, simply, if you want to say that. So persistent connections, cache control, consistent framework for content negotiation. This was basically to uh, have a you could take this as like the content type header. Okay, content type and accepts, the two headers that basically negotiate how the content should be transferred. So you use content type when you're sending data, and you use accepts when you're accepting data. So you basically tell the server that I'm sending this type of content, and when you send a request where you are expecting data, you tell it that I accept this form of content. So that that is that. Okay, those are the two things where you can negotiate about content. There are conditional requests. There are chunked content. Chunked content is basically sort of streaming. So you could chunk it and send it. This includes a specific header called transfer encoding. So when transfer encoding header is chunked, uh, your browser or your recipient knows that the data is not complete, at least in one packet. So there will be more packets. Then there was HTTP2, which basically introduced multiplexed sessions on top of TLS TCP. Basically, it said like, okay, HTTP is not able to handle like multiple connections. So what we'll do is we'll introduce another specification, and in that, what we'll implement is a connection multiplexing. So one connection could send multiple requests. Right now, with HTTP 1 or 1.1, you could only send one request in one connection. So one post request would create a new connection, transmit or exchange data, and then close the connection. And then for a different request, you will use a different connection. But for with HTTP 2, you could use one connection to send multiple requests. So if you have a post request and you also have a different, let's say a get request again, okay, then you could possibly send both of those on the same connection. So you don't have to make two connection to send two requests. You could use one connection and exchange data. So that was introduced in HTTP 2. HTTP 2 is like likely being adopted now. So the three major versions of HTTP was basically one, this 1.0, 1.1, and HTTP 2. The point 9 was basically later upgraded to 1.1 and then made a major release. So the point 9 and point 1, the 1.0 are considered almost the same. So what HTTP does is HTTP has this message syntax. We'll look at this. Okay. So there are a lot of things that we need to understand, specifically how the HTTP messages are structured. Okay. We're looking at B2 7030. Requirements in with okay, we want message format. Where is message format? Syntax notation. Okay. So there are a few things here. How asterisk operates repetition. Okay. Let's go back to yes, and we'll look over 7 to 30. RFC 7 to 30 is this one, which basically defines what is this? Proposed standard. Okay, there is a DOI. I don't want to read the whole paper. If you want to go ahead, look at this RFC and read the whole protocol paper. This basically defines how the messages are structured in HTTP and how the routing takes place. Again, there is semantics, content, conditional request, range request. Range requests are basically your chunk request where you want a part of a data. You have authentication, which is like authorization header, cookies, session cookies, all those things. Then there is again authentication info, proxy authentication info. You also have custom headers. So anything that starts with X dash, that is a custom header. You have client initiated content encoding. Yes. So I can request a specific type of content encoding, or I can send a specific type of content encoding. This basically means that I can encode the content, and the server, based on this header, will understand how to decode it. Two very common forms of encodings are gzip and Brotli. So two standard or two widely used content encoding. Gzip or yeah, gzip or bzip is is what you commonly see on standard implementations where people use that. The underlying library could be different, but yes, gzip and bzip are some common ones. Even Brotli is being used a lot. So what we'll do is we'll head over to Notion and we'll create a public document. I'll just create a public document. I'll log in and come back for you one sec. Let me log in and come back, and then we'll continue. Log in. Yeah, let's use my public account and okay, what happened? Something happened. Yeah, okay. So I want to go to my Notion. Yes, okay. Now we are here. So now we can use this Notion to create a public document, which I can, yes, new page. Where is public? Can I create a public document? How do I create a public document? Nah, I don't want to create a work account. Can I make this public? Can I turn it into a wiki? Page verification. Okay, I don't care. Just tell me how this thing works. No, no, I don't want that. I just want to make this public. Okay, I think we'll figure it out. First, let's just call it. I'll call it LameNet. This was one of the guys suggested in last community post. If you want to suggest content or ideas, you could head over to my community posts and drop a comment. We'll have a few things here to do. So let's note them under tasks. And we'll have one thing that I want is okay. Let's have the syntax. We'll have some verbs which are like action to be taken. Then we'll have some authentication container which will store auth token slash info. Okay, I think that makes sense. Then we'll have some data container which will store data being exchanged. So this will be both ways. And because we are writing a protocol, it's not specific to a certain side. So the protocol basically will define which how this message is transmitted irrespective of who is sending and who is receiving. The protocol is only a definition. Okay, so that is another thing that we need to keep in mind. We have syntax. I think let's just call it method syntax. We'll use TCP layer and text-based exchange. So what we'll do is the things again will be very similar to HTTP. So we'll take inspiration from HTTP whenever we'll feel like. But yes, in this stream we'll only define the specs and a few other things. Let's see. Okay, Notion did give me a login. Let's see what else. What else do we have? So we have a few things. This is important for us. This is important for us. This is important for us. The message syntax. Is the stream stuck? No, I don't think the stream is stuck. You might have your connection information, your internet might be having some problems, Shreya, but I don't think the stream is stuck. Let me check. Let me check. The stream is not stuck. Come on, come on, come on. My live is not published. No, no, the stream is not stuck. The stream is fine. Yeah, I'll just drop a message here. Okay, so we'll continue. It might be our own connection that's creating problems, but okay. Okay, so we have verbs, action container, data container. We'll use TCP layer, so that will make things a lot easier for us. We don't need to use binary very specifically because then it will involve a lot of work, okay, including writing the whole codec for it. So that will be another thing that we need to take care of. Um, One more thing that I was thinking of was verbs authentication. Yeah, custom header like thing. So yeah, custom header. Okay. Another thing that I need to do is so instead of custom header, let's just call it headers. So we'll just call it headers or similar to exchange more information about the connection. Let's say. Okay, so this is going to be like a crude implementation of HTTP. You could call it that way. And we'll use this very lightweight HTTP. Let's call it HTTP light. Okay, we'll use this very lightweight HTTP to to create a chat-based protocol so that it won't involve a lot of things like making get requests or what. So it will be a simple connection, a simple dial connection, listening on a particular port, and that will help me understand how to write the codec. So that is another thing that we need to do. We'll be implementing the whole codec and potentially this uh, protocol spec more in the next stream. But right now, what I'm thinking is to just give you an idea of whoever is watching. Okay, I want you to understand what a protocol is before we dive headfirst into building or basically specking out a protocol. So it's very important that you know what we are trying to do before we actually start doing it. Uh, and I think that should give you a very decent idea of why I'm doing this. Because I've seen so far a lot of people who actually don't understand what HTTP is. They think HTTP is basically just there to exchange messages or just to make web API requests. Although the most wide use case of HTTP is to make API requests, but what I want you to understand is why HTTP works and how it evolved, how it started and how it evolved. Everything evolves. We'll write something very crude. We'll try it. We'll see a few problems and then we'll try to evolve the whole thing into like Charmander or something. I don't know. Plain reference. Okay. Uh, Another thing is specification. So in the specification, we'll have message syntax. We'll have verbs, uh, authentication container, data container, header. I think that's it. That should be enough. And I won't be writing the whole spec here. So I'll basically create another page out of this. Can I not create a page, turn into page? Yeah, nice. So now this goes, and now I think I can make this public. I'll probably make this public or something. How can I share this? I'll have to, yeah, I can share this. Uh, Anyone with the Notion link, yes, anyone with the Notion link can do it. Yes. And then I'll copy the link and drop it in the chat here. And I'll also add it in the description for this video, this stream. Uh, Notion document for specification. Yes. Okay. So now the link is in the chat box if you are here, if you look back, and it's also in the stream description if you want a reference later. So this document, this public document, we'll keep updating it in future streams, and we'll keep writing more information here. Okay. Another thing that I want is let's write with AI. Let's see if AI can write. So let's see. Draft a message syntax syntax for a chat-based protocol, which will be similar to HTTP protocol, but will be very light and easy to encode, decode. It will also support versioning. Let's see. Let's see if the Notion AI can write. Okay, it's doing something. Okay, I think I do like this. So this is very similar to what HTTP uses. Um, yeah, I'll keep this. Okay. So I think this makes sense. We'll use the Notion AI in near future again, but I think this is a very good way for us to proceed, because then we'll keep building on this. We'll keep this as um, yes. So content length is there. Then we have two new lines. So one here, one here. So two new lines, and then the message content. This will be very similar to what HTTP uses. So instead of saying HTTP 1.0, we'll use this. Okay, and also if you don't want to do this, you could use HTTP itself and send headers accordingly, and that would also do your work. But what I want to do is basically build a codec around this, so that I don't have to use a lot of bloat on what HTTP is. Also, I think I don't because if I'm writing a codec, I could use this whole structure, and I could then understand and write my own codec around it. So that would help me to basically use a single connection to send chat messages between like two people. So it might become a peer-to-peer protocol. And if you're building like a room or something, then yes, we might be able to send messages in a room and then broadcast it. So the sender is this, the receiver is this, and based on this receiver, we might be able to transmit messages. So anybody in a particular room would actually make sense. So the receiver could be a room, The receiver would normally be a room, but individual people will have their own private room. So it's like that. You could consider it like that. So every person is their own room. So every person has their own private room, which is their account, and then they could make public rooms. So that way, we'll make this like a group chat by default, but also allowing private chats by making each user their own room. You could join a user, which basically means you're starting a chat with them. So this is a example message. So the length is 13 because this is 13 characters long. Version is 1. Type chat, yes. Type ACK server uh, to this user, okay. Okay, so this is that. Now we could take the AI again. We could ask the AI again to make this to restructure this so that we only use one single connection if required. So I won't have to write a lot of things by hand, and also we won't have to create a new connection because of because this is basically a peer-to-peer thing. But what I want is, let's start with peer-to-peer thing, and let's see if we can then upgrade again like HTTP did from CMP 1 to like CMP 1.1 and add a group chat, then maybe CMP 1.2 and support some more stuff. Okay, we have a few messages, ACK or ping join these. We'll also add another one for auth, authenticate the user, authentication request by the user. Yes. So auth will have a reply. Okay, so message type will be auth from the user, and then server will also send an auth request from server to the user, and based on that we could authenticate. We could basically try to uh, use the same thing. What we'll do is we'll start with a single connection, then we'll try to multiplex connection. So we might have a single connection with back and forth. I'm not trying to over engineer this. I'm just trying to build a protocol uh, based on like HTTP, and then use something around that. So it will be easier for us. I think that's good enough. We also got to use this. This is, I think, shared. Yes, so it is shared. And now you guys can go ahead, use this. I'll also add an icon or something. Let's see if we can use an icon. It's a net. So basically, let's try specifically a net. Like my good purple. We'll add a cover, change cover, and yeah, we'll add something from the games web. Come on, open up. Nah, I think this looks good. Looks open. Yeah, I think this looks good. We'll change it later, but I'll reposition it. This looks good. Yes, so that is fine. This also looks good. I don't want to add a comment. Yeah, do I? Yeah. So custom text based chat protocol build inspired from HTTP RFC and implemented using GoLang. I think that should be right. So now I don't need to. Okay, so I'll not do this. This is useless. Delete this comment. Useless. I don't want to add a comment. So yeah, and this into like heading 3 or yeah, a quote. That looks better. And this is a heading. So the quote is only this much. And I don't want a comment. So yeah, so we are good. I think this is good enough. We are now also done with, yeah. Hi Flippant. I think you joined in a little late. Check out, like keep an eye on Discord, because I think this is the end of the stream for today. We will keeping it very short. We'll have a little longer stream next time. I am having something urgent to attend to right now. But I'll, because now you're here, I'll give you a very short rundown of what we did in the last 30 minutes, and then you can go back and watch what we did. So we basically understood how HTTP evolved, how HTTP was built, and also why HTTP like introduced certain things. And then we basically went through, like glanced through the RFC, and then we have this public document. There is a message in the chat for the link. I'll drop you the link again, and you could go through this. We'll keep updating this document as we go, and we'll also be using AI along the way because I don't want to write everything by hand. So we'll use AI. So this message structure and everything is written by AI. So you could go back and look at it. We'll keep updating this document, and once we are done with the spec, okay. So the next stream would also be about spec. We'll complete this document, and then we'll start implementing it. So we'll use GoLang and the standard net package to use to build basically a codec around this, and that codec will basically simply uh, and convert this text message into binary and then binary into this message so that we can actually exchange some data, and we'll basically build a chat system around this custom protocol. It's all text based, so this is not like an HTTP header, but it looks very similar to HTTP. And that is the point. You could relate it to HTTP because this is a toy protocol. It's basically just implementing something. But the whole point of me building a custom protocol is to make you understand what a protocol is, what goes into building a protocol, what you think, uh, like what is your thought process when deciding on certain things of development, and when you think of things as products instead of just projects. So we'll make it like that, and we'll try to publish this. Okay, we'll try to basically publish a chat application somewhere, maybe on AWS or something. And most probably we'll be experimenting a lot on this, because again, this is a custom protocol. I'm doing this for the first time. You're looking at it for the first time, so it will be a lot. So yeah, I think that's a wrap for today. Uh, I was late. Okay, so that is why we are keeping it very short, because I only have 2 more minutes left before I attend something else, and I think that should be it. I'll be posting about updates on this on Discord. So anybody watching in the future, join the Discord, and you'll be happy. At least we have memes. We have memes around Discord, and we'll have fun. See ya. Bye.